Our third kind of special list-like structure is called a linked list. Now, unlike stacks and queues, a linked list isn't any different in the way we interact with it than a regular list. Instead, a linked list is different because of the way it works inside the computer. In order to understand that, though, we need to understand a little bit about how lists tend to work in advanced programming languages. So here we have, once again, the data stored inside the computer. We have a list of references and a list of values that correspond to those references. The numbers on top are the locations in memory, and the numbers on the bottom are the values that currently exist in those locations. Now let's say we have a list with 3 items in it. In older programming languages, those 3 items would tend to be 3 contiguous blocks. But that presented a problem because then if you tried to extend the list, you might risk running into some other data. So in more modern programming languages, each spot of that list tends to be a reference to a particular spot in memory that might be completely disconnected to the other ones. In effect, each spot in the list is more like an individual variable name that could point to anywhere in memory. So in this case, the first spot might point over here to 1103, the second spot might point to 1109 on the right, and the third spot might point to 1105. And as a result, the values of this list would be 5, 0, and 6. Each spot points somewhere in memory. In a linked list, on the other hand, instead of just the main list pointing to different places in memory, it only has one item that points to a place in memory, the first one. So to achieve the same result, that first spot in memory would point to 1103. What would make it unique is that instead of the second spot pointing to 1109, there would actually be data contained in the spot 1103 that itself would point to 1109. And then at the data located in 1109 would be a pointer to 1105. Each value of the list contains the location of the next value of the list. It's kind of like a treasure hunt. To find the final value, you have to trace through the locations of every previous value. Now, in advanced programming languages, that might seem kind of silly, but in older ones, that actually had some value. Some of the operations involved in the traditional working of a list would be very inefficient, and a linked list would make those operations a lot faster. For example, imagine if we had 5 values. In a traditional list, they would have the indices 0, 1, 2, 3, and 4. Let's say that now we want to insert a new value between 1 and 2. Well, that would mean we would have to change the indices of the rest of the list to 3, 4, and 5 to make room for the new value located at 2. In older languages, those changes could be very slow and inefficient. And even in new languages, that can still be slow and inefficient if you've got a really large amount of data. But think about it in terms of a linked list instead. Let's imagine for a second that coincidentally the values of our list were the first 5 values shown here in order. That would mean that the first one would point to the second one would point to the third one, third to the fourth to the fifth, and then the list would just be defined by a pointer to that first item. If we wanted to insert another new item between the first and second, say insert this item over here, instead of changing every single link in the list, we instead only have to change 2. We replace the link from the first one to the second one with a link from the first one to the new one, and we add a link from the new one to the old second one. So we only had to make 2 changes to insert a new item into the very middle of our list, compared to updating every index that followed the new item. In modern programming languages, this doesn't really matter that much, but it's useful to know about this structure, in part because you might hear people talk about it, and in part because it gives you a little picture about the way things are working underneath the hood. Or in other words, how they're working inside the computer.